Should have out worksheet 7 and the unit circle reference sheet. We're going to use both sides today. So the learning targets are to be able to solve trig equations. We're not going to do graphing ones today. We might need some trig traits. And we're going to do some factoring. So we're going to kind of focus on these two. Oh, okay, let's pause that video. I'm always supposed to tell you the learning targets ahead of time, but they don't make a lot of sense until we've talked about the lesson. So maybe we'll come back to them at the end and see if we understand what they meant then. But eventually, or along the way, we have discussed that the cosine graph, it's been a long time since we did graphing, it feels like now, but the cosine graph, remember, would start its peak on the x-axis and take until 2 pi to get back there. Does that look familiar to everybody? If I wanted to know where the cosine was 1/2, you could certainly look at your unit circle and find a couple places. Remember, cosine is the first one. So can anybody find me a couple places where the cosine is 1/2 on the unit circle? So you want to be on the unit circle side. Where is the x value 1/2? Pi over 3. And another place where it's positive 1/2 is it 5 pi over 3? Is that right? Okay. Now, if I asked for only the solutions between 0 and 2 pi, that's it, those two answers. But if it asked for all solutions forever, okay, with no interval, or they will say things like this, from -infinity to infinity, how often are those two answers going to repeat? Pi over 3 or 60 degrees. And then you could keep adding and subtracting what? Yeah, you could keep adding and subtracting 360 if it was degrees. If it's in radians, we have to keep adding or subtracting 2 pi as many times as we wanted, where n equals any integer. And I won't make you write that, but this means you could tell me 60, but you could also tell me 420, but you could also tell me -300. I'm just talking in degrees because that's how our brains work, but do you understand that that has many, many names? And that when you graph this cosine curve, it repeats and repeats and repeats, okay? And then the other answer, so that would cover the pi over 3 right here where it hit 1/2. And this one, and this one, okay? But to cover these other places, here, and here, and here, then we would have to say it's 5 pi over 3, and you could keep adding 2 pi multiples forever. Okay, so when it says no interval specified or forever and ever, then you have to put that plus or minus 2 pi n on. If the directions to a problem, one more time, if the directions say 0 to 2 pi, you just list the answers. You don't need any of that garbage on the back. All right. There's also shortcuts to write those. Does anybody recognize when you looked at your unit circle, there was pi over 3 up here that had a 1/2 as a cosine, and the 5 pi over 3 one was down here, right? Some of you might recognize that that's actually pi over 3 this way and pi over 3 this way. Because it is an even function, it could be shortened up to be written like this. You want positive pi over 3 or negative pi over 3. I don't care how long you write them, okay? So if you don't learn these shortcuts to writing them, that's fine with me. All right, so the algebra techniques we're going to use today include isolating the trig function, okay, like solving for a cosine or something, taking the square root of each side, factoring, and applying the zero product property. What is the zero product property? Anybody know? It's just that the whole idea of factoring is so that things can if you have two things that multiply, what has to be true? They multiply to make 0. Either A equals 0 or B equals 0. Do you understand that idea? Okay, that's the whole idea of factoring. It has to equal 0. All right, applying quadratic formula, we're not going to do those. That's too complicated for me. Rewriting using a single trig function, that's where you have to use some trades. All right, so this again, how did we solve this, guys? This is ideas from the zero product property. What did we do to the first one? Factored out an x. And then we said x could be what? 0 or 7. Is everybody with me? Okay, I'm really scared if you're not. What about this one? Did we say take out an x here and set it equal to 6? That doesn't work, guys. How many things multiply to make 6? An infinite number, actually. Okay? 1/10 of 60 is 6. Okay? We don't want to know how to get 6. We want to know how to get 0. So what did we do first? We set it equal to 0 and then we factored. Do you remember this? Because this is really important. Factors of 6 that would make 5 would be a 6 and a 1. How did that work? Did that make a -5 in the middle? I think we're good. So x could be what? Whew. My loud class can hardly stand it. Is everybody okay? X could be 6 or -1? And that the first step had to be getting it equal to 0. All right. This first one is done for you in your notes, and I want to talk you through this. This is actually a very tricky, icky problem at the very end. But right now it says tangent times cotangent minus cotangent equals 0. We'll talk in a little bit about the fact that you want to make it equal to 0 and leave it. You don't want to divide anything off. So we're going to factor out a cosine of x. If out of this term right here, I took out the cosine, what would be left? Okay. If I divided this second term by cosine, or factored it out, what would be left? Yes, a -1. Good job. Does everyone understand? We've been doing identity work that this would now multiply to be cosine times tangent and cosine times -1 or minus cosine. So those are equivalent, okay? Now we have two things that multiply to make 0, so we do the whole take your turn being equal to 0. Either this one is 0 or this one equals 0. All right, and this we would solve and say the tangent is 1. All right, so looking at your unit circle now, it wants all the answers from 0 to 2 pi. I know it's already done for you, but look at your unit circle. Where do you find a cosine of 0? Well, cosine is x value, right? So where is that 0 in the x value occurring? Pi over 2 and? Is that it? It's the only place there's a 0 in the x value? 3 pi over 2. Okay, so we were looking for this and we found it at these two places. All right, where is the tangent 1? Remember, tangent is tricky. It's not on our unit circle. Anybody know where the tangent would be 1? It's when the x's are the same, right? So if you put square root of 2 over square root of 2, y over x would be 1. So where does that happen? Where's that ordered pair, guys? Pi over 4. It's also another place that it would be positive 1. Yeah, if these were both negative, Remember, tangent has a period of pi, so it's straight across the unit circle. These were not across the unit circle because these were both where you got a 0. So tangent is tricky. Okay. I don't think that was too bad yet. The problem with this particular problem comes here at the very end. It said in the original question, you have to be able to put those values in and it comes out 0. The problem is, go to pi over 2. What is the tangent at pi over 2? 1 over 0 is undefined, okay? So we actually have to eliminate those two choices. I would not put that on a quiz. It's just too tricky for me. Okay, they don't all check, only these two check. All right, do you see that on the notes here? It said tangent's undefined there, so the original, only those two work. That was definitely a tricky one. All right, moving on. You don't have this one, but this is a case of where you would square root. Okay, it says 4 sine squared x plus 1 equals 4. If I subtract 1 from both sides, it would say equals 3. What would I want to do next? If I had to solve that. The sine of x is what we're trying to get by itself. Okay, if you had the equation 4x squared equals 3, what would you do next, guys? Divide by 4 and then square root? You with me here? Okay, so we're going to divide by 4. And then we're going to square root. And when we square root, what do we have to remember? Plus or minus square root of 3. What's the square root of 4 in the denominator? 2. All right, if that's a sine value, can you look at your unit circle? Where does sine go, x or y? It's a y value. We're looking for plus or minus a square root of 3 over 2 back there. How many times does that happen on the unit circle? If it doesn't matter if that value is positive or negative, it happens 4 times, right? Okay, so 4 times. So it happens at, I think, pi over 3, is that right? 2 pi over 3, 4 pi over 3, and 5 pi over 3. So if the directions to this question had said find all from 0 to 2 pi, we would be done. If it said find all solutions forever and it didn't have this, then onto the back of all those, you'd have to put a plus or minus 2 pi n. Now, there's shorter ways to write that, but I'm not going to worry about it. Can anybody think of a shorter way to write that? If you know this one, how could you say it means this one too? Anybody know? We don't have to talk about it if you don't want to, but do you understand? Those are straight across the circle from each other, so are you really adding 2 pi to get to the next one? You're only adding 1 pi. So you could say this one plus or minus pi, and it would take care of both of those. Okay. You could call this one down here negative pi over 3. So the very shortest way to write that would say positive pi over 3 or negative pi over 3 and add pi on. But that's not a quiz. You don't have to know the shortest way to write it. All right. So I think this is on your notes. It says when you solve for all values of x, in other words, there's no interval given. It does not say 0 to 2 pi. The solution should be represented as x plus or minus 2 pi n for sine or cosine, and x plus or minus pi n for tangent, because tangent has a period of pi, where n is any integers. Okay? This one is also already done for you, is that true? Help me isolate sine here. Okay, if you saw x plus 5 equals negative x, what would you do first? You want to add this x over here? Doesn't really matter. So add a sine x over here. What's a sine x plus a sine x? 2 sine x. And now the right-hand side is 0. Then what? We're trying to get this x or sine x by itself. Guys, it's not Monday. There's no really... Help me out here. It's even done on your paper for you. What do you want to do to get the sine x by itself? Subtract the square root of 3 over to the other side, and then divide by 2. So now you have the sine of x. You've isolated the function we're trying to find. Okay. The directions say all solutions. So we're going to need that plus or minus 2 pi n business on the back. We're looking for a sine value. So that's back here of a negative square root of 3 over 2. Can you find the 2 places on your unit circle for me? Nice and loud, somebody. Where is there a sine value of negative square root of 3 over 2? 4 pi over 3 and? Okay. And because it says all solutions, we have to say and every multiple forever. Because if we graphed this, okay, the sine graph would continue to hit square root of 3 over 2, negative square root of 3 over 2, over and over and over and over. Yes? All right, here we go. Wake up, take some notes. Where's the cosine negative 1? All solved for us. All we're doing is looking for a negative 1 in the x spot. And it says all values. So where's there a negative 1 in the x spot? Only happens once, right? Where does it happen? In radians. It happens at pi. And if it wants all solutions, how often is it going to repeat? Plus or minus 2 pi, every multiple of 2 pi. If we graph the cosine graph, guys, this is 2 pi, right? Another 2 pi. It happens that it hits negative 1 right here at pi, and 2 pi later, and 2 pi later, and we could have gone this way, 2 pi. Do you understand, guys? Okay, so this is our answer. X equals pi, and every multiple that we add 2 pi onto it later. All right, when trig functions cannot be combined to simplify on one side of an equation, we might need to try factoring. In order to factor, it has got to equal 0. You can't use factoring if it doesn't equal 0. It says we might need the quadratic formula, but I'm not assigning anywhere we need quadratic formula. Can you just look up here for a second? If you had this equation, sine squared minus sine x equals 0, you would need to factor out a sign and set them each equal to 0, because you will get where the sign is 0 and where the sign is 1. That's 2 solutions, okay? What students sometimes try to do is if they move this sign, they add it over to the other side, and then they divide a sign off of each side. What would happen there? Over here, you would just have sine x equals 1. Okay, is that the same number of solutions? No. So it says, watch out, do not divide by trig functions, okay? Do not divide by trig functions because you will lose some of the solutions. All right, so what could we factor out of this bad boy? This is a messy one. What could we factor out here? got it cubed, but we can take a sine x out. Okay, if we had a sine cubed and we took one of the signs out, we'd still have a what? Sine squared of x. Minus 4 sine x, we took the sine out, we'd still have a minus 4. Is that completely factored? This is two perfect squares, so how does that factor? We got the one out front. But here, sine squared minus 4 is a sine x plus 2 and a sine x minus 2. It's like an n squared minus 4. It would factor n minus 2, n plus 2, in whatever order you want to write it. Everybody okay with that factoring? So what are the three values that we have found sine could equal? If we set each of those equal to 0, we'd have sine is 0. Or sine is what? Yeah, negative 2. And you don't need to write all these steps if you can do it in your head. Or positive 2. Okay. You're going to find there's a whole bunch of these that don't work. And this is one of them. Here's the sine curve. Remember, it goes through the origin. What does the sine curve max out at? 1. And the mins are at negative 1. So it can hit 0, but can it hit negative 2 or 2, a plain sine curve? Garbage, garbage, a lot of extra work we didn't need. Okay, but this one can happen. The sine is the y value. So where are the values where it hits 0 on the unit circle? The y value is 0. Pi, and either 0 or 2 pi. I usually call it 0, and I'll explain why in a second. This does say all values, so you could call it 2 pi, it wouldn't matter. What do we need to, how could we write that if it's all values? What do we need to throw on the back of those? Plus or minus 2 pi n. Now, is there a shorter way to write that? If your answers occur here and here, how far did you really travel to get to the next solution? Pi. So the shortest way would probably just say plus or minus pi n, every multiple of pi. 1 pi, 2 pi, 3 pi, 4 pi, they all work. Okay, but this is fine with me. What was I going to talk about? I was going to talk about why... Oh. Let me just, we'll hit this idea again. But if the directions for this question had said this, everybody with me? Do you see that that includes 0 but doesn't include 2 pi? How it's got that parenthesis there? So you would have to call this one 0 and this one pi. You can't call it 2 pi because remember that parenthesis means it does not include 2 pi. All right. But that's not what the directions said here, so we're good. All right, what can we take out of this one? This is a product. It's a sine times a cosine. This is a product 3 times cosine. They both have in each of those products the word, the function cosine. If I take it out, what's left? Guys, this is one of the, this is like the whole focus of chapter 5, solving equations. Okay, everything we did until now was just to get us ready to do this. So please be paying attention here. Take a cosine out, what would be left? This term would have left a sine x. Back here we would have left a minus 3. Okay? Take your turn being equal to 0. This would say cosine x equals 0, or sine x minus 3 equals 0, which would mean the sine of x equals 3. Okay, where on the unit circle is the cosine 0? Meaning the x value is 0. Pi over 2. and 3 pi over 2. Did they give us an interval of answers, or did they say forever and ever all answers? All answers. So what do we have to throw on the back of those? Plus or minus 2 pi n, because it was a regular cosine, which repeats every 2 pi. There's shorter ways to write that. Okay? Anybody have a question about a shorter way, or are you just going to write them this way and be good? All right. What about where the sign hits 3? Does that happen on my unit circle anywhere? Does it happen when you graph a sine function? No. Cannot equal 3, so we're done. All right. What about number 4? This is one where someone is going to be tempted to divide both sides by sine. What did we talk about that? Don't do it, okay? Because you'll lose some of the solutions. So instead, we're going to make it equal to 0. And then what can I take out of both of those? Good, a sine x. I'll have left 2 sine squared x minus 1. Is everybody okay with that? A sine cubed, taking out or dividing out one of the signs would leave a sine squared. Okay, this doesn't factor further nicely. So we have the sine of x equals 0, or 2 sine squared of x minus 1 equals 0. These actually all have solutions. This one's pretty easy. The sine is 0 where? Where's there a y value of 0 at the back? 0 plus or minus 2 pi n, and pi plus or minus 2 pi n. How did I know I needed that plus or minus 2 pi n business on the back? Because it said for all solutions. All right, those work. This one is messy. It actually works. What would you do first if I told you to solve 2x squared minus 1? Add 1, divide by 2. So you would get sine squared, add 1 over to the other side, and divide by 2. You'd have 1/2. But then when you square root both sides, what do you have to remember? It's plus or minus. Okay. Anybody know what that simplifies to? What's the square root of 1? 1. What's the square root of 2? Square root of 2. What do you have to do to rationalize that? So it becomes plus or minus square root of 2 over 2. Is that on your unit circle? A lot of times, right? We want where it's positive or negative. So I need the value at the back to be square root of 2 over 2. Start listing. Where does that happen? Pi over 4. 3 pi over 4. 5 pi over 4 and 7 pi over 4. And it said all solutions. There's a lot of solutions to that. Let me show you why that is. If I were to graph a sine graph, okay, it said where it hits 0, does it hit 0 a whole bunch of times, guys? And positive square root of 2 over 2, which would be a line up here somewhere, and negative square root of 2 over 2. Do you see how many solutions there are? Lots and lots and lots. Now, does anybody want to try to write that shorter? These are actually pi apart, so you could say 0 plus or minus pi n. These are actually straight across from each other, so you could have said plus or minus pi over 4 plus or minus pi n. Okay, that's probably one of the shortest ways to write it. You don't have to. Write them all out is fine with me. All right, solve this one. Oh, we in luck. Look at the directions. What does this mean? We only need the answers that fall between 0 and 2 pi. We don't have to put any plus or minus garbage on the back. That's what that means. It says only the answers between 0 and 2 pi. Now it does say we can include 0, but not 2 pi. So if we need that spot, we're going to call it 0, not 2 pi. All right, so what do we do first here? We could subtract the 1 over to the other side, but there's no squared or anything. We don't need to factor. We just need to isolate the function. Yeah, I would just divide by 2. So you're going to have the cosine is 1/2, and that's an x value. Emma, can you tell me a spot where the cosine hits 1/2? 5 pi over 3? Is that what we said? Or pi over 3? Okay, sorry, pi over 3. Can anybody tell me another spot? Is it 5 pi over 3? Is anybody having trouble finding these? Do I need to pull a unit circle up here? You doing okay? All right, the next one is messy, but there's no squared. We don't need to factor. So let's see. What do you want to do first? Yep, they're both like terms. Yep, you could just combine them. 5 minus 7 is a negative 2. Plus 2 sine x equals 0. Then what? You could have moved them over to the other side first. It doesn't matter. We're going to add this 2 over to the other side. And then what? Divide by 2, and we end up with the equation saying the sine of x is 1. Where is that true? Sine is y, so we're looking for a 1 in the back. Does it only happen at pi over 2? Yep, that's it. So that's our whole answer, because why don't I need the plus or minus on the back? Because it says only between 0 and 2 pi. Uh-oh. Oh, we're still between 0 and 2 pi. That's good news. What do you want to do here? We cannot divide by a trig function, so we're going to subtract this over to the other side. 4 sine squared of x tangent of x minus a tangent of x equals 0. What can I take out of both of those? Tangent of x. What will that leave here and here? 4 sine squared of x. Is that it? Minus 1. Okay. Is that fully factored? Aren't those both perfect squares? 4 is a perfect square, sine squared, minus 1. So how does that factor? 2 sine x and 2 sine x. Factors of negative 1 are plus 1 and minus 1. Do you see where that middle term would cancel out if you FOILed it all together? Okay. So what values are we looking for? We're looking for where the tangent is 0. Do I need to show the steps here, or can you solve that for sine by yourself? 2 sine x plus 1 equals 0 would be the sine of x has to equal what, guys? Subtract 1 to the other side and then divide by 2. Do I need to show all those steps? I can. If you were doing this one, 2 sine x minus 1 equals 0, you would add 1. Divide by 2. So you'd have the sine of x is 1/2. Everybody okay now where I'm getting all those numbers? All right. It says all, no, it only says 0 to 2 pi. Oh, thank goodness. 0 to 2 pi. So we don't need any plus or minuses. We just need everywhere on the unit circle where the sign is negative 1/2 at the back, or the sign is positive 1/2, the y coordinate, or tangent is 0. Well, the only way to get 0 is to have y over x be 0. Is that working? Okay, tangent is y over x, so we need the y to be 0. All right, so where are those happening? Anybody? Where's the tangent 0? Isn't it 0 on pi? Can't call it 2 pi because remember there was a parenthesis there, but that same spot is also called 0. All right, where's the sine negative 1/2? 7 pi over 6 maybe? Is that right? And 11 pi over 6, how did I do? And then positive 1/2 is at pi over 6 and 5 pi over 6. Did I get those right, guys? For the sine value to be 1/2, or do I have them wrong? The y value is 1/2, yes? Okay. You can list those in any order, but all of those are the solutions. All right, try this one. You guys can do this one. Isolate the radical, or isolate the function, sorry. Add square root of 3 to the other side, divide by 2. And find that number on your unit circle. Am I looking for an x or a y, Ben? Cosine. Okay, x value of square root of 3 over 2. Got your unit circle? Where does that happen at? And does that seem right, guys? Anybody disagreeing? Okay. And it said only between 0 and 2 pi, so we're done. All right. You also sometimes have to use trig identities to trade things, okay? It says be sure to carefully check all solutions when you're done. Again, I'm not going to ask you any that they don't check. This one is done for you. It was gross because it had a tangent squared and a secant squared in it. Okay. Is there an identity? Can anybody find an identity, though, that has a tangent squared or a secant squared? Let me do this. White, white, white. I'm going to cover all this up. Maybe. Here we go. The reason I know I need a trade, I don't want a box, I want my pen. Okay. I know I need a trade because it says 2 tangent squared of x minus a secant squared of x plus 3 equals 1 minus 2 tangent of x. I can't deal with a tangent squared and a tangent and a secant squared. It's not going to work. Okay, but because there is a plain old tangent that I can't replace it with, I think I can't replace anything with into that spot. I think I'm going to have to replace this. All right, I'm going to simplify a little bit first. Well, I can't do much. I can subtract this 1 from both sides. And that would become a 2. I mean, eventually it's going to have to equal 0. Okay. What is a secant squared, guys? You don't need to write this down. It's done on your paper. It's a gross one. I won't ask you this one, but what's a secant squared? Look on the back side of your unit circle. A secant squared is a... I want a tangent. Is there something with a tangent? Is it a tangent squared plus 1 or a 1 minus tangent squared? It is a tangent squared plus 1. So I would have to distribute this negative. So I'd have 2 tangent squared of x minus a tangent squared of x minus a 1 plus 2, and I'm going to add the 2 tan over to this side at the same time. Okay, really grossed out right now. But this would combine to be 1 tangent squared of x plus 2 tangent of x. And back here, I'd have a plus 1. Is that what they have at some point on your sheets, guys? Do you see a tangent squared plus 2 tan plus 1 on the notes? Okay, that factors tangent of x plus 1, tangent of x plus 1, because in the middle you'd get 2 tangent of x. So if we set that equal to 0, we'd have the tangent of x could be negative 1. If I set that equal to 0. Where's that true? Where's the tangent negative 1? Tangent is not on my flipping unit circle. Anybody know where we would get a negative 1 if we wrote it? When we put the y over the x, would that be negative 1 right there? Square root of 2 over negative square root of 2. And down here, when I put the y over the x, wouldn't that give me a negative 1? So what are those two spots? 3 pi over 4 and 7 pi over 4. Was this a 0 to 2 pi or everywhere? Okay. Is that the two answers that they had? All right. All right, we will continue tomorrow. Your homework tonight is Delta Math, Trig Equation Solving Part 1, okay? I think in Delta Math, they are all 0 to 2 pi. You don't have to put the plus or minus 2 pi ends on the back. Does that make sense? All right, so tomorrow we'll finish this, and then there's a page more of practice, and we're going to do some together, and you'll have to finish it. Have a good day. Please try these tonight.